So the pH scale, how to measure the acidity of something. Does anyone else have an idea? Acidity of something? Yeah? Anyone want to take a guess, another guess at this? So I think that this is a relatively good definition. We will look at what it is actually measuring in just a second, but I'm sure that you have heard of the pH scale, especially, and yes, I'm probably going to be going on a rant later today about health stuff and people talking about like, oh, your water is alkaline and that's good for you or whatever. We'll talk about that in a minute. So when we look at a pH scale, oftentimes it will look something like this, okay? It'll look something like this. Acidic, neutral to alkaline, or sometimes people call it basic. Okay? When I was in high school, the term alkaline was used, but we mostly used as basic. Science has moved away from using the term basic. But acidic, alkaline. So Hannah's definition was measures the acidity of something. Well, but the lower the number, the more acidic something is. So it's kind of the opposite of measuring the acidity of something, right? It's the higher the number, the less acidic it becomes. So we go from 0 to 14. It is possible to go off of this scale. It is possible to go off the scale. The other day in AP Chemistry, we may or may not have made a solution with a negative pH. I can neither confirm nor deny that. Because when we put the pH meter in it, it just read 0. But I'm relatively certain it was negative because we put some cotton balls and some apple slices in it and they just disappeared. So yeah, it was real acidy. Okay. So oftentimes the pH scale looks like this, or sometimes they'll give you some examples. Battery acid, stomach acid, vinegar, orange juice, tomato juice, black coffee, urine, water, seawater, so pure water and salt water, baking soda, indigestion tablets or antacid tablets. Let me zoom in on this a bit. Soapy water, ammonia, bleach, drain cleaner. Okay. So we can go really across the whole scale, and you can see that you really don't want to mess with anything that's on either end in terms of like ingesting it. Okay? Anything outside of this range gets dangerous. Seawater and baking soda, baking soda and seawater together would not probably taste very good. Very bitter. So on this end, the more acidic something is, the more sour it will taste to you. The more basic or alkaline something is, the more bitter it will taste. So this side is sour, this side is bitter. Okay. Alkaline tastes bitter. Acid tastes sour. Oh yes. Well, I have pretty bad reflux, right? Stomach acid is less sour and more burny. It doesn't really have too much of a taste. It just feels like it's burning. And that's why when you throw up and like you get stomach acid coming out of your nose or whatever, it burns. Have you never had stomach acid come out of your nose? What?
I've never thrown up. No.
You've never thrown up?
Well, I've thrown up, but I haven't had it like come out of my nose.
Yeah, I had it all come out of my nose.
Huh?
That stuff hurts.
Yeah, you gotta like, yeah, it's no bueno. Anyway, that was a fun little aside. So yeah, so this is what a pH scale generally looks like. Again, what does it mean if we look at this? This gives us a very good indication of what we are actually measuring. In the pH scale, we are measuring the concentration of hydroxide ions or hydrogen ions. The higher the number of hydrogen ions that we have, the more acidic it is. The higher number of hydroxide or hydroxyl ions, the more basic or alkaline it is. Okay, so we have free hydrogen protons here. We have hydroxide protons here. An OH minus and an H plus. Remind me what an ion means. Remind me what an ion means. Jay, what? What? Huh? This, hydrogen? Yep, hydrogen ion. Vince, remind me what an ion is.
It's a
Charged particle. And it does a really good job of telling us that what charge does this ion have? This is very obvious. It's a positive, right? And this one has a negative charge, meaning that a hydrogen ion is just a proton. It's just proton, no electron, that's it. Might have a neutron with it, maybe. OH minus is an oxygen and a hydrogen, and they found an extra electron somewhere and they yoinked it. Okay, because the oxygen, if we look at our periodic table, the oxygen wants 2 more electrons in its valence shell. And the hydrogen is willing to give up 1. They need another one to be to cosplay as neon, right? Together. So they find an extra electron somewhere and they snag it. What happens if we combine an OH minus ion with an H plus ion? What happens? What do we get? H plus OH would give us, come on guys. It's like the one chemical formula that you all know. H2O. Okay? Pure water is neutral because it is H2O. And it has and every once in a while, an H plus ion will pop off of a water molecule and make an OH minus ion, but they are in equal amounts in fresh water. Why would seawater have slightly more OH minus? Salt. The polar molecule of sodium chloride will pull some hydrogens away from the water, some water molecules, and so you'll end up with a bunch of OH minus molecules, or OH minus ions just being liberated from the solution. So that's why salt water, seawater, is slightly alkaline, is because of the salt. Okay? Does this make sense? Concentration of hydrogen, concentration of hydroxide. Cool? Okay. Don't change it yet. Okay. All right. So here's what's interesting about the pH scale. Let's get a more exact definition here. So the pH scale is a representation of the amount of H plus ions and OH, I need to capitalize that H, my bad. H plus ions and OH minus ions in a substance. Generally, solution. Okay. H plus ions, OH minus ions. This, not only is it a scale that shows us that it is a logarithmic. What is a logarithmic scale? Does anyone have any ideas? Franklin, I can see you do. Anybody have any ideas as to what logarithmic means? No? So a logarithmic scale is a scale where each step takes us up by not like a factor of 1, but a factor of 10. So for instance, let's look at this here. This scale does a pretty good job of demonstrating this. Really? It's not what I wanted. Not what I wanted at all. Dang it. Okay, there we go. You see this? Concentration of hydrogen ions compared to distilled water. 10 to the 7th, 10 to the 6th, 10 to the 5th, 4th, 3rd, 2nd, 1st, 1, which is 10 to the 0. -1, -2, -3, -4, -5. So, how much more acidic, in terms of like times more, how much more acidic is something 0 than 2? Vince? 100 times. So something with a pH of 0 is 100 times more acidic than something with a pH of 2. Something with a pH of 2 is 1,000 times more acidic than something with a pH of 5. Okay? So with the pH of 5 is 1,000 times less acidic than 2. And so here's what's interesting. I think we're measuring the concentration of hydrogen ions, which are H+, right? Which the more we get, the lower the number gets. So Hannah's definition of how acidic something is actually completely true, but the numbers are backwards. Is that confusing? Yes. But we're measuring the amount of free hydrogen ions in something in comparison to distilled water, which is perfectly neutral at 7, because there are equal amounts of hydrogen and hydroxide ions in distilled water. Okay? And then something with a pH of 14, is 10,000 times more basic alkaline, or you can also think of it like this, 10,000 times less acidic than something with a pH of 10. Yes.
So what does pH stand for? I'm assuming that H is a hydrogen ion, but what is it?
Yes, I believe that it refers to parts of hydrogen. I think, and let me look specifically here. pH scale, pH stand for, internet? Power of hydrogen. Sorry. So the like this, not like the power, the strength of hydrogen, but the power to which we are raising the 10 of hydrogen. Does that make sense? Ashton? Two minutes. Okay. So 0 to 14. All right. So here's a question for you. What if we combine a solution with a pH of 5 with a solution with a pH of 9? What would happen? What would their pH be? Yeah.
Neutral, because they kind of like cancel each other out.
Correct. They would cancel each other out. And what kind of chemical reaction would we get? Cancel each other out. So if we have something with a pH of 5 and we mix it with something with a pH of 9, the resulting solution would have a pH of 7, which is neutral. But now I want you to consider what would happen chemically to the hydrogen and hydroxide ions. What will they make? Thoughts? It would not combust, but they would combine exothermically to make water. Combustion, in order for combustion, we need molecular oxygen. We don't have any molecular oxygen in this example. We're just considering the H pluses and the OH minuses and what happens there. So really what we do when we combine something with H plus OH minus, yikes, that is ugly. OH minus gives us H2O, right? Okay. Now let's consider a common base and a common acid. And let's see what happens when we combine them. So let's think about sodium hydroxide. So the name of this is sodium hydroxide. What do you think the pH of a sodium hydroxide solution would be? Would it be alkaline or acidic? You think acidic. Pourquoi?
Because it has H plus instead of
Sorry. This isn't a plus like the ion. This is that we're adding it to something. So what would sodium hydroxide? Just the NaOH. So alkaline because it has the OH. So anything with anything that you hear that has hydroxide as the last part of it, hydroxide is going to be basic or alkaline. Okay, sodium hydroxide. Now let's combine that with a common acid, which is carbonic acid. Sodium hydroxide plus carbonic acid. So what does it do? Well, it makes two very common things. When we add these two together, so I'm going to write this out again, just smaller. NaOH plus H2CO3, or you could write it. So here's what's interesting. Some people write acids the hydrogen first. Some people write the acids the non-hydrogen first. Both are correct. H2CO3, which I actually prefer this way because it shows us that the hydrogen is willing to come up and be free. Because I'm free hydrogen. You're welcome, Davis. I got one facepalm. That's what I was going for. Okay, this will make. Well, first of all, what do we know that this is going to make? If the hydrogen in the acid comes off and the hydroxide in the hydroxide is going to come off, what are they going to make? If a hydrogen finds a hydroxide and they get married, H2O. I feel like I've mentioned this a couple times before. Yeah? H2O, and then we're going to get one more product. And that product, so if we have the H's and the O's, we know that we're going to get a sodium because the sodium isn't here, right? And we know that we're going to get something else that is, let's see here, we have the sodium, we've got an O and an H, and we have an H, but what about this? We know that we're going to have a carbon somewhere in there. And because of the way the chemistry works, some of the oxygens tag along. You don't need to be able to predict that, but you should be able to tell me that there's going to be a sodium and a carbon that ends up somewhere because we have a sodium and a carbon and they're not in here. Okay, really what we make is, which you may have seen before earlier today, it's disodium carbonate. It is baking soda. What?
Is the type of chemical reaction single replacement?
That's a great question. So the type of reaction that we are having here is actually a double replacement. No, it's okay. Because what's happening is this H comes off and pairs up with this OH, right? And then this CO3 finds this guy. So they switch places. Double replacement, right? Trading dance partners. Okay? Questions on how that works? No, Mr. Croshaw. We understand perfectly how that works.
I have a question. Do you know how I'd be able to add the two things like together and get a product?
So what I want you to be able to do is when you see something that is a alkaline base combining with an acid, I want you to be able to say, I know that this is going to make water. And I also know that it's going to make something else that is generally a salt of some kind. And you're like, wait, sodium carbonate isn't a salt. Well, in chemistry it is. In chemistry it is. In chemistry, anything that is an ionic bond between something that is on the left side and something that is on the right side of the periodic table is called a salt. Okay? So sodium carbonate is a type of a salt. Okay? It's not table salt, but it is a salt. So you should be able to tell me when we have an alkaline and an acid, mix them together, we get water and salt. Okay? Pretty much. Yep.
So like FR and RN.
RN does not react because it's a noble gas. But francium, I forget what AT is because we never use it because it doesn't exist for very long. It's not adamantium. No, so francium, again, we don't use that very often, but francium iodide would be a salt. Wouldn't exist for very long, but it would be a salt. Probably not. Most salts you can eat. In fact, most like for instance, salt that is like driveway salt for roads and stuff to de-icing. Most of that is like a magnesium sulfide or magnesium chloride.
You can't eat that kind of salt, right?
I mean, not in a large amount, but it would be safe to have a little bit. I wouldn't season your tortilla chips with magnesium chloride, but
Why not? Isn't that
yeah, I mean in small trace amounts.
yeah. So,
Again, just a little bit. Just don't.
on my way to keep the periodic.
Yeah. There's a great chapter in What If about which, if you haven't read What If, it's fantastic. What would happen if we made a periodic table actually out of the elements of the periodic table? And the answer is like past element like 30 past, once you get that like lower down, things start getting real crazy. So even the top stuff, I mean chlorine, right? Chlorine's no bueno. Sodium's no bueno.
Chlorine's fine. Don't want
All right. Okay. Questions so far?
Yeah, what happens to the tangent about water?
Oh. Fiji water? Okay, so a lot of people will talk about water, or like, yeah, most of the time it's water. Most of the time it's water. And they talk about how your drinking water needs to be alkaline, or your drinking water shouldn't be, or should be slightly acidic or whatever. And a lot of people like distilled water, like it's perfectly neutral. You're good, okay? You're good to drink water that's anywhere between like 6.5 to 7.5. Okay, once once you get into stuff that's like an 8 or a 6.0, then it starts getting questionable on whether you should drink it or not. Obviously, certain acids are really good for us.
What can you drink like 9 alcohol?
A 9, again, you could, a 9 is like closer to a antacid solution. It neutralizes the acid in your stomach.
Isn't that what Trump did?
And that's what Tums do, yes.
Oh, I got heartburn the very first time. It sucks.
Yeah, welcome to my life. My wife, the first time that she had heartburn was with our second child, when she was pregnant with our second child. And she comes up to me, Preston, why does my chest hurt so bad? I was like, what does it feel like? She's like, it really hurts, and like sometimes it hurts like up in my throat, and it feels like it's really hot. Like you're experiencing heartburn. She looks at me, oh my gosh, I'm so sorry, because I have heartburn like 2 or 3 times a week, like pretty serious heartburn. Yeah, because stomach acid is very acidic. It's like a 2, right, on the pH scale. So maybe it should chill. Yeah. Well, it has to be kind of overpowered to break apart all the stuff that you're not chewing when you eat. Next time you go to Texas Roadhouse and you get yourself a big old slab of steak and you get a chunk on your fork and then you just put it in your mouth for like 4 seconds and chew and then swallow it, and your stomach acid's like, see, this is why I burn you sometimes. Okay, I have to deal with this crap anyway. Yeah, so pretty interesting. Here's one for you. What about a very common reaction that you all know about, which is vinegar with baking soda? Vinegar with baking soda. Who has done this before? Mixing vinegar with baking soda. You make a volcano, right? It's the classic baking soda. Home remedies. See, this is the kind of crap that drives me insane. Home remedies to lighten your skin. Don't do this. Don't, oh my gosh, get out of here, guys. Okay, I can't handle it. Oh, we still don't, oh my gosh, we're still getting some bull crap. Guys.
Did you see the rainbow vinegar?
The rainbow, this? That's pretty cool. Okay. Give me something worth actually looking at. Thank you. All right.
Keep going down to find something.
No, if you put the word formula into anything, all the anti-science people have a conniption. So we're safe here. We're safe. Okay, so behold.
This is not true. They all have like a secret formula. They just don't want to show it.
Behold. You mix vinegar with baking soda and you get water, which we know about. We also get carbon dioxide. Is carbon dioxide a salt? It is not. This is one of the few cases that we don't get a salt out of it. Okay? But when you combine vinegar in your, little volcano and you put the vinegar in there and you pour some baking soda in there, what happens? Your volcano goes, right? What is actually occurring there? Why does it bubble? Chemistry. Yes, thank you, Jenny. Because of the carbon dioxide. Carbon dioxide is being rapidly released out of the vinegar, which So this is the colloquial term is vinegar. The scientific term is acetic acid. Acetic acid, which is essentially saying acid. Acetic, so vinegar, vinegar is actually the thing that we kind of figured out acids through, because it's a very common thing. Does anyone know how vinegar is made? It's generally made as a byproduct of making alcohol, oftentimes wine. White vinegar that you can get is oftentimes made as a byproduct of making or distilling tequila and vodka. No, because it doesn't have any ethanol in it. Because it's been distilled out. But
Not that that would taste good anyway. So if you were on a desert island and had, for some reason, the same amount of vinegar and baking soda and little vials, could you mix them and then wait for the carbon dioxide to drink water?
Yep, absolutely. Yeah, if you just have like a whole bunch of vinegar and you're like, man, I am thirsty, and you're like, oh, look at this baking soda over here. Yep, you just made yourself water. But you'd better make sure that it's stoichiometrically balanced.
What you're saying is that you carry around vinegar and.
Or you could just have a water bottle. I mean, that works too.
If you don't look at the trouble with vinegar, if you put it in there's like too much vinegar or just like vinegar.
It will be very, very acidic water. Yes.
What if you put too much baking soda?
Then it'll be very alkaline water.
So just figure it out.
I'll just get-
So figure out the stoichiometry. No.
Can you just tell us what this week
Yeah, on your desert island, you're gonna call me up. Mr. Croshaw, I have this large bottle of vinegar and a large container of baking soda, and there's no fresh water on this island.
You probably.
You know our cell service.
What's the stoichiometry? I could look this up, seeing that I have cell reception right now, but I wanted to call you.
Don't
We said
bother
like
calling anyone.
LTE service. You're
Yeah.
shot.
Okay, so that's what I wanted to talk to you about today. I'm going to finish the video here. Like and subscribe or whatever.